this one, for the moment, if I give you the formula for what will be the formula for the moment, formula for the moment will be, yes, Mustabshir, formula for the moment will be, moment is equals to F into D. So it would give you the
FNCD,
same
yes.
SI base units, kg m square s minus 2. Got it? Because for force it is
Yes.
kg m s minus 2, and D will be just multiplied, so it is kg m square s minus 2. For momentum, formula is, yes, yeah, what is formula for momentum? Defining formula for momentum?
Uh, or mass times velocity.
Yes, that is mass times velocity. So it is kg ms minus 1. That is its SI base unit expression. For strain, is represented by this. It is actually change in length per unit original length. So it has same units, so no unit at all. So for SI base, for strain, you will write nothing, no unit. Is it clear to all?
Yes, sir.
Okay. For your pressure, what is pressure actually? Pressure is force per unit area. So it will be kg ms minus 2, ms minus 2 upon meter square, and that will give you kg m minus 1 s minus 2. So it is same as for Pascal. So you will have the same SI base unit for Pascal, you will have same SI base unit for pressure. And then very interesting fact here, that stress has the same formula. You know what is formula for the stress? Stress has the same equation, which is basically stress is equals to force per unit area. Right? Is it clear to all of you people? Stress is equals to force per unit area. So your force
Yes.
is what? Again, kg m square, sorry, kg ms minus 2 divided by area is m square. So you will write kg m minus 1 s minus 2. So for stress it is. Now for Young's modulus, the game is a bit different. Yani, for Young's modulus, Young's modulus is E, and that is equals to stress upon strain. So what unit I told you for the stress? Yani, let me write in words. It is stress upon strain. Stress upon strain. So what is the unit I have given to you? Stress के लिए unit है kg m minus 1 s minus 2, and strain has no unit. So overall, what will be the unit?
This is same as stress, kg meter
Yes.
inverse
So
second.
it is same as stress, kg m minus 1 s minus 2. So if there are some questions which are asked, that which of the physical quantities are units have same SI base unit. So here all these on this slide, pressure has same SI base unit equation as stress, and that has the same SI base unit as Young's modulus. Will it help you out to solve these type of questions now?
Yes, sir.
Yes,
Okay,
sir.
अब इस पे आइए. The electrical charge. What will be the formula for electrical charge? I mean, defining equation. You have learned a lot of formulas, but what will be its defining equation? Defining equation for the charge is that the charge is uh, Q equals
Uh,
I times T.
IT. Yeah.
Yes. So I is measured in ampere and time is measured into second, and SI unit of a charge is coulomb. So its SI base unit is ampere second. So for charge, for coulomb, what is SI base unit expression? SI BU, that is equals to ampere second. Will you remember that?
Yes, sir.
Okay, now let's talk about potential difference. Potential difference is what? Potential difference is work done per unit charge. Defining equation. Again, I'm telling you, defining equation. And defining equation is this. So work done is equals to force into distance. Is it?
Yes, sir.
That is force into distance. And this is I mean I into T. Am I right?
Yes, sir.
I into T. In theory, you have to show the working, or the questions in which it is written show that there are very important. Show that type questions. In those questions, you have to show all these working. It's very, very important to know for the exam point of view. Then in MCQs, no need to show this all, just put all the values according to your convenience. You can make the steps shorter and you can get the final answer. So here, what will be that? It will be kg ms minus 1, sorry, ms minus 2 into meter divided by ampere into second. So what will be the final value, Mustabshir? Kg m square s minus, sorry, it was minus s minus 3 a minus 1. So SI base unit of potential difference is this, is it?
Yes, sir.
Okay. Now if I ask you that what is SI base unit expression of EMF, EMF, so EMF is defined as, what is the definition of EMF?
Work done per unit
Same.
charge.
Yes, very good. Word done per unit charge. So again, in show type questions, you will do the same, F into D divided by I into T, and again kg ms minus 2 into m divided by ampere second, and that will give you kg m square s minus 3 a minus 1. Simple. Is it all clear?
Yes, sir. Clear.
Yes, sir.
One more thing from here, that potential difference and EMF, they have same SI base units. Is it?
Yes.
Okay,
Yes,
good.
yes.
Now, electrical resistance. For electrical resistance, you have the defining formula that R is equals to V by I. So when I say that for R it is equals to V by I, old R is equals to V by I. So it is V is basically equal to V is work done divided by charge, and this ampere, yani this I will be written as simply ampere, no issue at all. It would be just written as it is. Then work done will be written as F into D, and Q will be written as ampere into second, and this ampere green wala, and now this becomes F into D divided by ampere square into second. So you will say kg m square s minus 2 divided by ampere square s. So final answer will be kg m minus, sorry, m square s minus 3 a minus 2. You got this point?
Yes, sir.
Okay.
Yes.
So this is basically all. There is another physical quantity which I have noticed it is asked to you. That is intensity. So defining equation of intensity is energy per unit time per unit area. So how can I manage that? Energy divided by time is power. So power divided by area. So again, power is your kg ms minus 3, because we did it in the last. But if you have to show type question, then you have to just show it by making that power is equals to energy divided by time. So then you will not actually go to this side. Then you will just continue by this method, that energy is work done, which is kg m square s minus 2 divided by second, and this is basically divided by a, so it would be now area will be multiplied here, na, is it? So kg with my negative sign, sorry, negative sign. So kg m square s minus 2 m minus 2 because area has power, area has unit meter square, so meter minus 2 will be there, and second, so if this would be gone, so it will become kg s minus 3. This is the unit for your intensity. Is this clear to you?
Yes, sir.
So
जी सर
this
एक
all was basically,
सर ये
yes.
एनर्जी बाय टाइम के ऊपर ये होल डिवाइडेड बाय एरिया, इस वजह से वो ऊपर जा रहे हैं.
नहीं, मैं एक साइड पे इसको कर देता हूँ, जस्ट अ सेकेंड. I have written in this way that intensity is energy divided by time per unit area, huh? So you can draw
जी
it
सर अब समझ आ गया.
as
ठीक है
area by 1.
ठीक है.
So that is why area energy divided by time into 1 upon area कर दोगे, तो जब ये ऊपर जाएगा तो it would be basically -1 हो जाएगा. ठीक है?
जी ठीक है सर.
Is it clear or should I explain it more?
Yes, sir.
Clear.
Clear.
क्लियर.
Okay, now the second part of your SI based unit was basically homogeneity check. So we talked about that. That homogeneity check means correctness of any physical expression. So there are different physical expressions which are either correct or not. For example, do you believe that E is equals to mc square is a correct equation? If it would be, if it would be E is equals to m square c, then what is the check, or what is the basically criteria to show that E is equals to mc square is correct but E is equals to m square c is incorrect? We have some rules, we have some criterions, and that is rule number 1: you have to ignore the constants without units and numbers. Actually these are the same things. Yani when you are going to remove, or when you are going to ignore the constants without units, then it is. Then rule number 2: just plug in the values, right? Place the values and simplify. Yani place all SI units, sorry, place all SI units and simplify. Rule number 2 is fine. Place all SI units, yani SI base units, sorry, not SI base, SI base units, SI base units, and then simplify. And finally, actually here, if for two terms equations, left hand side should be equals to right hand side, right? And for equations for three terms equations, SI base unit expression for all terms must be same. Okay, I mean equal, right? Now I will have some past paper questions here. Which of the following could be measured in the okay, so that is what we are done with, right? We have completed that. Now the homogeneity check. The homogeneity check means this whether uh, derive the SI base unit expression of this C. SI base unit expression of the C is to be checked by, just let me check that whether is there any specific question in my questions that value of G determine the derived units of pressure explain your working. Wait. No. Actually, the checking of homogeneity, I can give you that example. Yani, what example I have figured out E is equals to mc square. That can be just set as one of the example. For checking of the homogeneity, for example, if you have an equation T is equals to 2 pi L upon G. This is the random equation. And if I just prepared this equation, or if I have just written this equation, I must have some evidence that okay, this equation is correct. Again, I have another equation for you, that um, the radiant flux intensity, and this is not required for you that you have to recall that. Radiant flux intensity is basically luminosity divided by 4 pi r square, where luminosity is equals to power radiation or power radiated by the star, right? By stars. So I'm just moving to these equations, whether they are homogeneously, whether they are correct or not, right? So let's check the first one. What is the rule? What rule I told you? You have to ignore the constants, because 2 is constant, pi is constant without unit. So I have to ignore it. Beta pani de do, please. Very pyari beti. Okay, so I will select left hand side. For left hand side, which equation do you have? Which equation do you have? At left hand side, you have time. So what is its unit? SI base unit second, na? For right hand side, what do you have? You have L divided by G square root. So you will place all the values and then you will simplify. So I'm just placing the values here. What is the SI base unit of length? It is meter. What is the SI base unit expression of G? It is meter per second square with square root. Don't keep it without square root. So what? M and M will be gone. Your equation will be s square root, and then your square and square root will be gone. So what you get? What did you get? Second, is it? So can I say that left hand side equals to right hand side? Is it? Because its SI base unit is second and its SI base unit is second. So do you people hear me?
Yes, sir.
Yes, sir.
Yes.
Okay. Is it there? Any confusion?
No, sir.
Beta see any confusion?
No, sir.
No, sir.
No, sir.
Okay, good. Now carry on with this one. Uh, Basically, this is what this is your, I have mentioned that it is your radiant flux intensity. The important thing for these type of questions is to check read the script, because you will read the script. So please read the script first. When you are going to read the script, in the script it will be mentioned that what is this and what does it mean. So for example, that F is radiation intensity or radiant flux. It will be given to you, don't worry. It is in our A levels too, this equation, but it does not matter here. This equation is asked to you. It is the part of physics, radiant flux intensity. So this is your click, that if it is intensity, I have to use the SI base unit of intensity. So for right hand side, sorry, for left hand side, I'm just making it as an intensity. So as I told you that for intensity, what was the SI base unit equation? If you recall, it's fine. If not, then you can calculate that it was power divided by area. Is it? Do you know that? That power divided by area? So it is kg m square s minus 3 divided by m square. So it would be gone. So that will give you kg kg s minus 3. Kg S minus 3. This is the radiant flux intensity or the SI base unit expression of your left hand side. Now you will go to the right hand side of your equation, and for right hand side, what do you have? 4 divided by, sorry, you have L divided by 4 pi r square. So Mohsin, Mohsin, what I have to ignore from here?
सॉरी सर रिपीट करें.
What I have to ignore from here? यहाँ से मुझे ignore क्या करना पड़ेगा?
सर राइट हैंड साइड वाले में से.
लेफ्ट हैंड साइड वाले, हाँ राइट हैंड साइड वाले से, सॉरी.
सर इग्नोर लेंथ में मीटर होता है.
नहीं 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 नहीं. Anyone else?
सर
Yeah.
आर्ट्स को
What I
इग्नोर
have to
करेंगे.
ignore?
Yes, sir.
What I have to ignore from this equation, which is not of my use?
So can you ask again?
I'm saying, do you see this L divided by 4 pi r square?
Yes.
So what I have to ignore from this?
The 4 pi.
4
have no
pi.
unit.
Why?
They have no units.
Mustabshir,
Yes.
why? Because they have no units. So just ignore it. I mean, don't write it. Mohsin, beta, is it clear to you?
तो सर जिसकी यूनिट नहीं होगी उसको हम निकाल देंगे.
Yes, जिसका यूनिट नहीं है इसको निकाल देंगे. Rule number 1, the
Okay,
first
ठीक है.
rule,
ठीक है सर.
okay, that ignore all constants without units and all numbers.
सही है सर.
Are you getting my point?
जी सर.
Well, so I have ignored it, and when I have ignored that, the remaining stuff is L by R square. What is the remaining stuff? L by R square. So I will plug in all the SI base units. So SI base unit of length is meter, and SI base unit of radius is meter square. Is it? Oh, sorry. L is not length. Sorry, my bad. L, I told you to read the script, and here I have mentioned it is power. What is this L? This is power of radiations. So it is actually power. So this is a click for me that the unit of the power is kg m square s minus 3. So I will just plug these values here. Meter and meter square and meter square will be cancelled again, and I will get kg s minus 3. So did you see that left hand side is equals to right hand side? Do you believe this?
Yes sir.
Yes, sir.
That is the homogeneity check of any type of equations. Now, if the equations are homogeneous, you can derive the SI base unit expression of any of the unknown. For example, here your C is unknown, so you are supposed to calculate the SI base unit expression of this. So first make this C as a subject. So it would become F divided by R into V. Here F is what? F is your force. So force is what? It can be any type of force, but it is a force. So it will be kg ms minus 2 divided by radius is meter. Sometimes this radius can be represented by a, l, whatever, and meter is ms minus 1. So what is the unit of this? Meter and meter gone, and you will get kg m minus 1 s minus 1 will be cut by one of the minus 2's. So this is that unit. Is it clear to all?
Yes, sir.
So in this way, we will proceed from SI base unit expressions. Here, the pressure of this is the theory part. The pressure P due to the liquid density rho is related to the depth of H, where G is the gravitational acceleration. Use the expression to determine the derived unit of pressure. So isn't it very easy? Just put all the SI base unit expression for right hand side. Right hand side, and enjoy the answer. Okay. This is another. Show that the SI base unit, show that the units of the quantity D are kg m minus 1 s minus 1. So this is the same thing. You have to ignore 6 pi, put the value of f, make this d as constant, and it would be d will be equals to f divided by r into v. We did the same, is it? So they can be of different formats, but your answers can be same. So this is another important aspect to find the value of any exponent. This is the extension of your SI homogeneity. Now, if the equations are homogeneous, you people are asked to do that. That please calculate, please find out the SI base unit, sorry, the value of this n. For this purpose, just because I have to wind up quickly, so here I'm going to write the rule that put units, SI base units, simplify and compare for powers. And what to do? Compare for power. Power mean for individual variables. I will solve one of them and then it will help you out. For example, here is I will rewrite this expression in the slide above. V is equals to k delta p by rho whole power n. What is this? V is equals to k delta p divided by rho whole power n. And what is my task? I have to find out the value of n. Yani the value of n is unknown. So what is given here in the script? Everything is very important. Delta P is change in pressure, rho is density, and K is constant with no unit. It means it would be gone, ignored. And what is the value of n, where V is the speed? V is speed. So all these values will help me out. I will ignore the K and I will write V is equals to delta P divided by rho whole power n, and then I will plug in the values of SI base unit. So meters ka speed ka unit SI minus ms minus 1, then pressure is kg m is, sorry, kg m square s minus 1, sorry, no, kg m minus 1 s minus 1 na? Just do that. Pressure is equals to force by area. So force is kg m square s minus 1 s minus 2, and divided by area is, no, force this is 1, area is square, so it would be kg m minus 1 s minus 2. This is s minus 2, sorry, this is pressure s minus 2, and here density is kg m minus 3 whole power n. Now you will just cut wherever it is to be cancelled out and further simplify. Further simplify is, on one side you have ms minus 1, on the other side you have m would be shifted upward, so it would be m square s minus 2 and m square s minus 2 whole power n. Are you getting my point? Sorry for very quick services, but I have short time, that's why I have to make it for you. Is this clear to all?
Yeah, it's
Yes.
clear.
ms minus 1 is now m square whole power n, yani m power 2n into s power minus 2n. So moving onward, now did you see m is on the left hand side, m is also on the right hand side. So when you will compare the variables, here the power of m is 1 and here the power of m is 2n. So from here n is equals to 1 by 2. Is it clear? Now the same
Yes, sir.
thing can be repeated for s. When I will write for s here, it will be minus 1 on the left hand side and minus 2n on the right hand side. So sorry, minus and minus would be gone, so n will be again 1 upon 2. So that means that your n has the power 1 upon 2. So this is the right option. Is this type of question, Yani, will you be able to handle these type of questions now?
जी सर.
Yes, sir.
Good. The last aspect is to determine the unit of any constant. Yani, this is we have practiced this. And how did we practice? You have to make that constant as a subject and simplify that all and enjoy the answer. For example, here you have to find the value of k, sorry, SI units of k. So you will make k as a subject. It will be t square m divided by r cube. Again, you have to study the script that what is t is time, so it is second square, and mass is kg, and divided by radius is meter cube. So it will be your kg second square meter minus 3. Kg second square meter minus 3. Option C is correct. Is this type of question clear to all of you? So this was all about today's lesson. That I mean, now I'm quite sure that you will not have any issue in physical quantities and measurements. Only one thing which is still left with that is your estimations, right? I will talk about the estimations later on, inshallah. Okay, so now please solve each and every question of your physical quantities and measurements. I will talk about vectors tomorrow, inshallah.
Okay, sir. Allah Hafiz.
Okay, see you then, inshallah.
Okay.